Okay, on problem number 1 and 2, basically you have to solve for y on each one in order to graph it, or you can use the intercepts. On these two, I suggest you just solve for y. Notice on this one right here, you simply had to subtract the 3x to both sides, and you get a slope of -3 and a y-intercept of 5. That is this one right here. That's this line right here. Then, the second problem is you had to add the x on both sides, and then you had to divide everything by -1 in order to get this equation. So it's a negative slope, and -1 is the one, that's this line right here. And notice what they meet at 3, -4. Alright, so now what we're going to do is we're going to move that off to the side. We're going to bring in this one. Now, on problem number 2, you just kind of look at it. This equation's already solved. The second equation, you had to add the 4x to both sides, divide by the -2 on every term, and you get a negative slope with a y-intercept of 4, and your intersection is at 0, 4. On problem number 5 and 6. Alright, let's take a look at this. You had to solve this by elimination. Well, if you notice, this problem here, we're going to multiply everything by 5, and you end up getting 5x plus 10y equals 15. In this case, since your x's are the same, we subtract everything right here. So 5x minus 5x cancels out. 10 minus 3 is 7. 15 minus 8 is 7, and you get y is equal to 1. You go back up here, you plug it back into one of the original equations, and you got x equals 1, and your intersecting point is 1, 1. On number 6, it's a two-line multiplication. Notice we're going to eliminate, and I want you to notice something. This equation right here, 2x minus or equals 8y minus 2. Well, what they ended up doing, and they don't show you this, but they subtract the 8y from both sides, making it 2x minus 8y equals -2. This is when they multiply this whole thing by 3, and how they get 6x minus 24y equals -6. And that's the line you see right there. Okay, so make sure you follow that step. Now it's real easy because basically they're going to subtract. The x's cancel out. This becomes a minus, this right here becomes a plus because you're subtracting. So plus plus. So -24 plus 6 is a -18. They then divide everything by -18, and you get a +2. Take that, plug it back into the original equation, and you got x equals 7. Notice on number 7, you have to determine which one is quarters, which one is pennies. So you have to define your variables. They're going to let quarters equal x. Now notice quarters came first in the problem, pennies came second, and had a grand total of 120 coins. So we know that number of quarters plus the number of pennies is going to equal 120. But then it says that the coins added up to 1632. So well, you know a quarter is 25 cents. So if you do 25 cents for every quarter plus 1 cent for every penny, that's going to add up to 16.32. And that's how they got the equations that they got. All right. Now, this one, they're going to use the substitution rule. It just seemed easier because you can manipulate this equation by moving the y over. They got x equals -y plus 120, or in this case, they used x equals 120 minus y. They then plugged that in right here for the y value. They distributed the 25 cents. All right, so let me go ahead and I'm going to erase this. I'm going to erase all that. Now, if you notice, they did substitution here, and they distributed the 25 cents. And then once they did that, they combined -0.25y and 0.01y to give you 0.24y. Now, one of the things that looks like it's missing is that 30 right here. So this 30, well, what they did was they subtracted 30 from both sides. And when you do that, you get a result of -1368. You then divide both sides by -24 cents, and you got y is equal to 57. You then plug that back into this equation right here, and you get 57 plus something is 120, therefore that something is 63. And in the end, you need to say, since x is 63, that means you have 63 quarters, and you have 57 pennies. And that's what I want to see on your test. Okay, now on number 8 and number 9, what they're showing here is that the progression on solving for y. So basically what they don't show you is that the 2 minus 2x, or 2, sorry, let me go ahead and erase that. The 2x minus 4y is less than 8. Well, what they don't show you is they subtracted the 2x from the other side. And you get negative 4y is less than negative 2x plus 8. Remember, you're going to divide by negative 4, and what ends up happening is that sign has to change. So this sign is going to flip. So you end up getting y is greater than 1/2 x minus 2. And that's how they got this equation right here. Well, you start at negative 2 right here, and it's up 1 right 2, up 1 right 2, up 1 right 2, up 1 right 2. And that's how, now remember, it's dashed. And that's how they were able to make this line. Now if you look, they chose the point 0, 0. When you plug in 0, 0 into this equation right here, you get 0 for y greater than 1/2 times 0 and then minus 2, and you end up getting 0 is greater than negative 2, and that is true. Therefore, they shaded above. Now on number 9, let me go ahead and erase all this. On number 9, it's a simple straight line. Remember, y equals goes this way. These are all the y equals. And x equals go vertically, because those are all the x's. Now, let me go ahead and erase that. Now, remember, on this particular one, since it's y is greater than negative 3, that's the same as saying y is equal to negative 3. So, I want you to notice something. Actually, on this problem, here's negative 3 all the way across. Okay, it's a solid line based on that inequality. So if you plug in 0, if you test the point 0, 0, well, or actually if you says y is greater than negative 3, if you put your pin on the y-intercept right there and you ask yourself where are the y's greater than negative 3, that's going up. Therefore, it's everything above. Oops, and I messed up there. Everything above the line. Okay, on number 10, number 11, it's basically like number 8 and number 9. You have two equations. You're just going to happen to put them on the same graph. Notice this one right here is a dashed line. Okay, that one's a dashed line. Let me erase that real quick. And then notice, let me write the equations down. You have y is less than 2x minus 3, and y is greater than negative x plus 1. If you look at the y is less than, and you put your pen or pencil on the negative 3, that means that's the shading down below. Well, what they're showing you is this, it's this shading right here. And then what they're showing you, it's y is greater than, well, put your pencil on the 1, and at 1 that goes up, so that's all the shading to the right. Well, notice that they overlap in this section right here, and that's what you need to do. So let me go ahead and erase all this. So if you notice, the only part you need to shade or need to be responsible for is this double shaded region right there. And anything in that double shaded region, I can pick any point in this region and it will be a solution because it will satisfy both of those equations. Alright, let me go ahead and erase this and let's talk about the next one. On number 11, let me go ahead and blow that up just a little bit. Okay, on number 11, same thing applies. You have, they solve the equation to y is less than x. So y is less than or equal to x. Well, if you put your pin on the x-intercept, all the y's that are less than are going down. So notice the shading is down below. Notice they didn't shade this region over here. Then, on this other one, they end up getting y is less than negative 4/3 x, that's a 3. Plus 6, notice again it's y less than, so at plus 3 they go shading down. Well, that's this area right here. And notice the only thing they had to do was this double shaded region right here. That's the only thing you're responsible for. So let me go ahead and erase that. And so basically I only want to see this double shaded region here. So from here to here, anything on this solid line up until that point that's a dashed line, nothing on the dashed line can be a solution, but everything from here and the shaded region right here can be a solution. And that is it. Good luck on your test tomorrow.